Okay, so we are going to go ahead and move on to Unit 9, Day 1, Part 2, which is basically correlation. So we're going to continue talking about that. And we're also going to talk about outliers, which is also another topic that y'all basically covered in 7th grade, okay? So today with outliers, instead of them giving us the actual scatter plots, they're giving us a table and we're going to need to graph those tables. So we're not going to do example one. Of course, if you want to check after me, the answer is positive. Once you graph this table into Desmos, you're going to notice that it forms a positive correlation. So basically, it's going to look something like this. It's going to be increasing, okay? Something along the lines of that, okay? But the one I want to do is example two. We have a table and we're trying to figure out whether it has a positive or a negative correlation, what type of correlation it has, and how do we know? Okay, so if you go to Desmos, we're going to type in that table. Now, in case you forgot, if you click the plus, you will see the button that says table. If you click that, it will give you a table. And then for the X values is going to be your first column. For the Y values is going to be your second column. And after you zoom in or zoom out, you'll be able to see your your scatter plot. And if you notice, it is decreasing. So it has a negative correlation. Okay. So what type of correlation? Negative. Now, of course, if you wanted to draw a sketch, you can just, draw a sketch to indicate a negative correlation. Now, how do we know? Well, there's actually two ways. One is the obvious one, which is you graph it and you look at the scatter plot and you will see that it's a negative correlation, it has a negative pattern. The other way that you could have done this without graphing and using Desmos is to look at the table. Now, if you notice your X values are increasing by a value of 1, if you notice your Y values are decreasing, okay? So this is a basic form of something that's a negative correlation, okay? As your X values are getting bigger, your Y values are getting smaller. So if you notice, if we are moving towards the right side, my values are increasing, my X values are increasing, and my Y values are decreasing, which is clearly a negative. As for a positive correlation, if you're just looking at the table itself, your X values are going to be increasing and your Y values are also going to be increasing. So that is how you can tell if it's a positive correlation from the table. Okay? Now, let's move on to the back side, which is outliers. Okay? So basically, an outlier is a data point is a data point that differs significantly from the rest of the gathered data. Okay, so basically, an outlier is a data point that differs significantly from the rest of the gathered data. Okay, in other words, I typically like to say that this is an outcast point. Okay, because it stands out. So a scatter plot, an example of a scatter plot that has an outlier will be something like this. So let's go ahead and draw a scatter plot that has a negative correlation. And now an outlier will be something like this. The outlier will be that point I just graphed because as you notice, it stands out. It's very, different compared to the rest of the data that has been graphed on the scatter plot. So that's known as a outlier. Now let me give you an example. Okay, we're all taking a test for Math 1 and everyone, makes between 85 and 100. But then one person makes a 32. That test score will be known as an outlier. Okay, and of course, as someone who might be dealing with statistics, might be asking the next logical question will be, why does this test score differ? Why did this student didn't perform as well as the other students? It might have been attendance, it might have been behavior, and so on. Okay, and companies do that or use that that data to be able to answer questions that are relevant to their business and so on. Okay, so it's important to identify. It's important to be able to see that data and be able to see the outlier and understand, well, one, is there outliers in this gathered data, and if there is, why are they there? And it leads on to other questions. But anyways, for you all, you just need to be able to be able to identify the outliers. Okay, so let's move on to the last two examples. Identify the outlier of each data. So for number one, if you notice, we have 98, 99, 96, 34, 100, 99, 98. Clearly, the outlier will be 34. Okay? And then for number two, clearly, based on the scatter plot, the outlier is this point all the way out here. Okay? If you have any questions, let me know.